Hello everyone, welcome to the week 10 computer science periodic video. This time I'll be splitting this video into like two separate videos, one for the quiz and one for the past paper. However, the past paper video won't be actually solving past papers. For paper 1 questions, what I'll be doing is giving you specific formulas or ways to phrase your answer. However, paper 2, I'll just be solving straight up because there's no real way to solve it other than that. Anyways, with that out of the way, let's get started with the quiz. All of the following is true about a web browser except this one's pretty straightforward because you don't design the web pages or the websites with the web browser. You use a separate use a separate program. All of the following are functionalities of the firewall except essentially what the firewall is it's like a software or kind of like a software or hardware that just like stops any packets at like it stops any data packets and checks if it's malicious or not. So knowing that, let's just go ahead and read the options. May block access to specific IP addresses. That's kind of what I just said. It works by monitoring incoming and outgoing network traffic. Yeah, yeah, that is basically what I said. It allows users to create and design web pages. That's nothing about what I mentioned, so therefore it's this one. Which of the following are false about cookies? So cookies, they're just little text packets that are stored on the web browser that has to do with the user. So which ones are false? Cookies can cookies modify data in a computer without the user's knowledge? They can't. In reality, they don't really have any they don't have any ability to change what's on the computer. It's so one is definitely false. Cookies are a kind of spyware. Although they do technically collect information on you, they can't exactly be considered spyware because you've consented to the cookies tracking you most of the time. Cookies are used to produce website pop-ups. Not true. They can't really produce website pop-ups, so it's this. Which of the following is a logic expression that represents the logic circuit below? So here you're given a logic circuit. When encountering these types of questions where you have to create the logic expression from the logic circuit, here's what you should do. First, work your way from right to left. So start with the rightmost gate and then go on with the, and then just keep going backward until you reach the main inputs. So, but before we begin, you have to write the input z. So first, or output, I mean, write the output z. So z equals. Now that we have that out of the way, we need to find what gate is directly connected to the output, which is the OR gate right here. So in the middle about here, you can just write or in this case, I'll be using algebraic notation because it's easier to write. Now go back from the OR gate to see what gates it connects to. As you can see, it connects to two AND gates. So here, make two brackets, one for each AND gate, and then put a little dot there to represent AND. And then let's do this gate first. As you can see in this gate, it connects to the A and B inputs. And it's important to note it directly connects it to them. So you just immediately write A and B. Next up, we do this AND gate. As we can see here, it's directly connected to the C input, but first it goes through a NOT, then to the B. So to represent this, we write a little dash on the B, then C. If you don't understand the algebraic notation, which by the way you should because it's pretty important and you can get asked about this in the periodics. IGCSE not so much, but for the periodics just know how to read algebraic notation. This is read as A and B or not B and C. So now we choose this one because that's the one I chose. What's the name of the logic gate represented by the truth table below? So first let's analyze this truth table. So when 0 and 0 are false, it gives an output of 0. 0 and 1 produces an output of 1. 1 and 0 produces an output of 1. 1, 1, output of 1. What we can notice here is that anytime there's at least one true value or 1, 1, the output is 1, which is the case for the OR gate. In the OR gate, if either one is 1 or both, then it's an OR gate. Something is dedicated to stopping all data packets at the firewall and inspecting them before they are permitted to be transmitted. This the proxy server is dedicated to stopping all data. This one you just need to memorize. That the proxy server is responsible for stopping data packets at the firewall and inspecting them. Which of the following is true about digital currency? It has a physical form such as banknotes and minted coins. This is obviously false because we're talking about digital currency here. Digital implies the fact that it's on computers, thus it's not physical. It is a money-like resource that is managed, stored, and exchanged across computers. This is true because it's a digital currency. It's stored on computers. It can be used to purchase goods and pay for services. Obviously, because this is a currency, and usually with currencies, you're able to exchange it, and you could able to exchange it for goods and services. TLS is a type of digital currency. And TLS has nothing to do with currency and is just a security thing. It cannot be used online. If it wasn't be able to use it online, that would defeat the whole purpose of it because it's digital. So that's obviously not an option. This is the name given to the integration of sensors, controls, and actuators designed to perform a function with minimal or no human intervention. This is the automated system. Which of the following is true about session cookies? Select all that apply. They cannot be deleted. False. What session cookies are basically is they're cookies that are just temporarily stored for the specific session you're on. So let us assume that I have a session cookie stored by the web browser about a certain setting I have applied. Since it's a session cookie, this setting will immediately be lost if I had closed the web browser. They are deleted after the session is completed. True. They do delete them. They are deleted after the session is completed. They are stored in temporary memory locations. Yeah, this is true because, as I said, they are deleted. They are deleted after set amount after the session, so it makes sense for them to be stored in a temporary memory location. They do not collect information about the user's computer. True because usually when you're collecting cookies, you don't collect information from the user's computer itself. You usually collect information as like a certain preference or a password or cards or like items in a cart, let's say. Which of the following are true about persistent cookies? Now, persistent cookies are the opposite of session cookies. They're almost forever stored in your computer, but they do have an expiration date though. They help the website remember information about settings and preferences. True, because usually settings and preferences they're almost always stored in persistent cookies. They are deleted when the session ends. False, because like as I said, they're permanent. They're mostly permanent. They have an expiration date. As I just explained, they do have an expiration date. They expire after a certain amount of time. They are stored in a file on the computer's hard disk. This is true, since it usually is stored on the user's computer. They are not deleted when the browser is closed. This is true. As I said, they just aren't deleted. Which of the following is a type of digital currency? Select all that apply. Cryptocurrency is probably the first example of digital currency that would come to mind. And you also have virtual currency, which is basically just, I don't know. And you also have central bank digital currency. If you want a further explanation on this, I suggest reading the book or looking up a video about each of these things according to the Computer Science IGCSE syllabus. Which of the following are elements of an automated system? First, first things you have are the sensors. These are the things that take in inputs from the surroundings. Then we're supposed to have microprocessors or like something that controls the actuators, which I don't think there's a choice for here. And then we have actuators, which are the output devices of the automated system. Which of the following is a disadvantage of an automated system in the industrial sector? So we have to look for like basically negative things about the automated system, and specifically in the industrial sector. This it is expensive to set up is true for all automated system. It is usually expensive to set up any automated system, no matter what sector it's in. It requires preventive maintenance to be carried out periodically, increasing costs. Yeah, this is true with any type of machinery, really. If you have if you have like a machine, you will have to do maintenance on it to make sure it doesn't break down. It is difficult to transport and set up the system because it is made up of smaller heavy systems. This is obviously true, as is true with anything that's heavy. It's hard because any automated system is bound to be big, so it's obviously going to be heavy, which is going to be difficult to transport. Which of the following are input devices that can be used in an automated system to improve the quality of vegetables produced in the agricultural process? So first, since they're asking about input devices, so we need to make sure we choose anything that has to do with input, not output or control. A pump to dispense the appropriate level of nutrients in the water. This is obviously false because this type of thing would be an output device or an actuator. A pH sensor that checks the pH level in the water. This is this is an input device because anything that's a sensor is an input device. A ventilator that stabilizes the temperature in the system. This is false because this is causing a change. It's not measuring anything in the room, so this would be considered an actuator. An acidity sensor that checks the acidity of water. Like I said, anything that is a sensor is an input device. A thermometer that checks the temperature. This is this is true because it's checking something. It's taking inputs from its surroundings. Which of the following are advantages of using an automated system in traffic lights? By minimizing stop and go driving, automated systems help lower fuel usage and emissions. Yeah, because this makes sense because automated systems won't be running on a set timer unlike modern traffic lights. They'd be running on like specific factors. Like let's say how many cars are in this station, how many cars are in this part of the intersection, how many cars are in this part of the intersection, stuff like that. So it would realistically lower fuel usage and emissions. Automated systems require less updates and repairs, leading to lower maintenance expenses. This is false because, as is with any automated system, there's always going to be maintenance to it, which usually means higher maintenance costs. Automated systems can optimize traffic light timings based on real-time traffic conditions, reducing congestion. This is true because, as I just tried to explain, the timing of this traffic light would be based on factors and not on a set timer. Automated systems can reduce the likelihood of accidents by ensuring smoother traffic flow and better coordination. This is true. Implementing automated systems can be cheap due to the advanced technology and infrastructure required. This is inherently false because implementing automated systems into anything is going to be expensive. What process must be applied to analog data collected by sensors? So in an automated system, if you have any being collected by sensors, it's going to be an analog. But here's the problem. The microprocessors only understand binary data, not analog data. So they must be converted to digital or binary data for it to be understood by the microprocessors. What are the instruments that collect data from various sources and can detect a specific parameter? That's the description of a sensor. A sensor basically just collects data from its surroundings. A coffee vending machine is an example of an automated system. The user presses a button to select the coffee, and then the machine heats the water. Once it is hot enough, the machine mixes the water with the coffee, and a small actuator opens the funnel to dispense the mixture into a cup. What are the sensors used in the below automated system? So when encountering these types of questions, try to look at like any inputs. So first we have here the user presses the user presses a button to select the coffee. This most likely implies like something similar to a button, which is close to a pressure sensor. So keep in mind anything with a pressure sensor and ignore everything else. Next up, we have once it is hot enough, implying that there's something measuring the temperature of the coffee. So this is why we choose this one, so it has both of what we're looking for. What are the advantages of automated system in agricultural sector? Select all that apply. Faster growth rates of crops than in traditional farming. This is true because usually in traditional farming, it's pretty hard to maintain the crops, so it's more likely to grow slower than if there was something that was constantly making sure it's growing properly. Initial costs of setup and operation are low. This is false. Almost always the initial costs of setup and operation are high. Optimal use and reuse of water, nutrients, and minerals. Yeah, this is true. Since it's an automated system, it's always going to be using it properly in a proper amount, like whenever it needs it. Reduced labor costs since the system only needs a supervisor. As is with any automated system, there has to be someone supervising it to make sure it's not going wrong. So obviously, it's going to reduce labor costs. What are the requirements of an autonomous vehicle application? Select all that apply. Information about the position and motion of the vehicle. Yeah, because you want to know where the car is or where the vehicle is. Information about the number of cars in the active city. Now you don't really need to know how many cars are there because here it's saying in the active city, not necessarily stating in a road or something like that. So in just the general city, it's not that important. Input about the state of the environment surrounding the vehicle. Yeah, this would be pretty good information to be collected by a vehicle because let's say you're driving on a slippery, icy road. The car should be driving more carefully if it's on such a terrain. Communication with roadside infrastructure or other vehicles. Yeah, this is pretty good to know because let's say you're at a stoplight and like you're just going through, you're just driving and the traffic light you're at just turns red. You wouldn't want the car to continue on driving. You'd need to know, oh, this has stopped. The traffic light has turned red, so I should stop the car. Information about the driver and occupants. Yeah, it would be pretty important to know who is in the car because maybe there's something fragile in there. Which of the following is true about cookies? They allow the user to browse the internet without the need for an internet connection. This is false and is practically impossible. For you to be able to access the internet, you need an internet connection. You need to be able to like communicate with the internet. They remember settings from the user's last visit to a website. This is true. Any cookie just remembers like settings or mostly anything from the previous user, from the last time the user visited the website. They determine new and returning visitors. Yeah, this is true because let's say this website has cookies about this person, so that most likely implies that this is a returning visitor. They store items in shopping carts. Yeah, this is true. Cookies store anything. They basically store anything. And they allow users to open a website without a web browser. This is false because for you to be able to open a website, you need a web browser. So just like with the first statement, this is practically impossible. Which logic gate has the below truth table? 0, 1, 1, 0. Okay, so basically you can instantly tell this is a 1 gate, a NOT gate, because there's only one letter input. But let's just analyze it just to make sure that you know this is a NOT gate. Whenever there's a 0, the output is a 1, and whenever the input is a 1, the output is a 0. As you can see, it switches whenever it switches the input, which is the function of the NOT gate. It flips the input bit to the other thing. What is the logical expression that represents the above statements? For light Z to be on, A, B, and C must be on at the same time. So let's analyze this question. So what they're saying is for light Z to be 1, A, B, and C must all be equal, must all be on at the same time, or must all be 1. So there's most likely an and somewhere, and more specifically two ands, because we want an and between here and an and between here. So the logic expression should look something like this. Or if you want, you can just do A and B and C, which I don't suggest doing it like this, but in the quiz they do it like that. But always when you're writing a logic expression, write it like this. And by the way, this is the same thing as uh, A. This is the same thing as this, just letting you know, because you'll still get the same output. So you choose this one. Which of the following is not a logic gate? This is obviously sand, because there is no gate called a sand gate. And the following figure is the blank gate. So, so first we should just analyze this thing. Okay, so first, one thing we can notice is it has the like half elongated circle shape, which is a characteristic of the AND gate. However, you'll notice this little circle here. This little thing inverses the output of the gate. So basically similar to a NOT. So this is now an NAND gate. So this gate is called a NAND gate. The following figure is the blank gate. Okay, so here the shape is similar to the OR gate. And there's a little circle there, so it's an OR gate. Which of the following figures is the NOT gate? So from memory, you should notice that this structure is the NOT gate. And by the way, just letting you know, if you ever have to draw a gate in a written part, make sure you draw these inputs or outputs, or else you will lose marks. Trust me. So which of the following is this gate? Well, obviously this one. This is the NOT gate. And let's just cover these so you know. This is the AND gate, the XOR gate, the OR gate, and the NAND gate. There also should be a XOR gate somewhere, which is just the OR gate with a little circle on top. And the output of the two input OR gate is false when. So right now it's asking when is this gate false, produces an output of 0. First we should refer back to the table, or the truth table. Okay, so let's have a look at this truth table here. For the output of an OR gate, it's true whenever there's at least a singular one, which is the case here, here, and here, meaning leaving this output to be false. Since it's asking whether this is false, which is this one, we should see when we should see that it's either when both inputs are 0. So let's look for anything that mentions both inputs being 0 or false. Only when both inputs are false. Yeah, as seen in the truth table, it's either 0 or 0. An XOR gate is also referred to as an exclusive OR. This question is pretty simple. A NAND gate is when you apply a blank gate after a blank gate. So essentially what this question is asking, what is equivalent to this gate? What two gates are equivalent to this gate? So whenever there's this little circle on top, you should know that there's probably a NOT gate. So extend the line from here, and then have the AND gate, because this is obviously AND. So we draw the AND gate. So meaning that if you put a NOT gate after an AND gate, you get the NAND gate. For which gate does the following truth table belong to? 0, 0, so let's analyze this gate, or this truth table. So first when we have the input 0, 0, we have an input of 0. Already this is looking quite familiar. 0, 1, 1, 1, 0 gives 1, and 1, 1 gives 1. This is practically the OR gate we just did a couple of minutes ago. So OR gate. For which gate does the following truth table belong to? So just immediate off the bat, looking at this, we can notice is the opposite of the truth table of the question before it, which was an OR gate. So if it's the inverse of the OR gate, it must mean that this is the NOR gate. For which gate does the following truth table belong to? When we analyze this truth table, we can notice that it's true only when there's two different values. If it's 0, 0, it returns false, and if it's 1, 1, it returns false. So it must be the XOR gate. Which two input gates output is 1 if one of the two outputs is 1? So first we should have a look of the truth table of each gate. If either one of the inputs is 1 for any two input gate, so instantly get rid of the NOT gate because there's only one input. Now we must look for anything which is true if either one is 1. So obviously we can get rid of this one because it's only true if 0 and 0, if A is 0 and B is 0. Secondly, we can also get rid of this one for the same reason, because it has an A is equal to 0 and B is equal to 0, and thus it's true. And it's true, so we get rid of it. For the OR gate, it holds true if either one is 1, and if both are 1 actually. So you select this one, and you also select this one because it's only true if both of them are 1, which in a way fits what's being asked of us. So you choose the OR and the AND gate. Which gates is or are not used in the below logic statement? Select all that apply. So whenever you see a gate in this equation that's in the choices, you just cross it out. So we can see a NOR gate here, so cross it out. We have an OR gate here, but there's no OR gates, but if there was, you'd cross it out. A NOT gate here, so you just cross that out. An AND gate here, cross that out. And once again, an OR gate, which we do not have, leaving these two to be the answers. Consider the following logic gate. The output is true when this is the AND gate, which is true when only both of the inputs are true. So this one. Consider the following logic gate. So here we have the NAND gate. The output is true when. So we know that the AND gate is true only and only if both of them are 1. So we just want the inverse of that, which is whenever A or B or both are false. Consider the following logic gate. Here we have ourselves a NOR gate. The output is true when. First we should refer back to the truth table of the NOR gate, or the OR gate. If you remember, it is true whenever there is a 1 inside, if either one was 1. So for this to be true, both inputs have to be false. Consider the following logic table. The output is true when. Here we have ourselves a XOR gate. For the XOR gate to be true, either one has to be 1, but it can be both. So you can say that if A and B have different values, then the output of the XOR gate is true. Name the logic gates used in the following logic circuit. So before answering this question, we should ignore the wires because they're of no use to us right now. So first we have the NOR gate here. So we select this one because of the NOR gate. Then we have the NOT gate here. So you select the NOT gate. Then we have the OR gate. You select the OR gate. And then last but not least, we have the AND. So you select the AND. So let's look at the following logic circuit. First we have a NOR gate here. So let me write NOR in the middle, or plus this whole thing, because the dash above anything means NOR, so the dash above anything means not, so if you put it over the plus it should be OR. Now we draw the brackets for the next step. First we have A XOR B, so A XOR B. Next up we have this one, which is a NAND gate. So inside this bracket draw another line, dot B and C because it's connected to the B and C inputs. And before answering this question, you should know that usually uh, logic expressions are commutative. So if you said B XOR A, it would be the same thing as A XOR B. So first, let me check. Here's an A XOR B, A XOR B, B XOR A, A XOR B, A XOR C. This is the only false. Everything else is true. And then we have the NOR gate here. So we have NOR, a NOR, a NOR gate, but we have an OR gate here, so we have to get rid of this. Then we have not B and C. So, or a NAND B and C. It's obviously not this one, leaving us with only these two. Which Boolean algebra describes the following circuit? Okay, so first, as I said, when working with logic circuits, start from the rightmost circuit, or the one closest to the output circuit, output wire, which is this gate. So write X equals a plus sign here for the OR, then the two brackets. When we trace this wire back, we realize it connects to a NOT and then connects to A. So we can say that this is not A. Then for this wire, you go back to the AND gate. It connects to B and C. So B and C. So we just need to find the one that matches this. First, you can get rid of this one because it has the AND in the center. Then you can get rid of this one because there's an OR where there's supposed to be an AND. Get rid of these two because there's nothing that inverts B or C, leaving us with this one. Now, the way they ask this question is honestly quite complicated, but let's just simplify it. So first, like I said, start with the centermost gate. So Q equals OR, and then make the two brackets. Next, we go back to the OR gate until we reach the next gate, which is an AND gate, so put an AND here. The AND gate then connects to the inputs A and B, so just write down A and B. Then we go to the input of the next then we go to the next input of the OR gate. So trace back until we reach this gate, which is an AND gate once again. Then trace back to this input of the AND gate. We get to this OR. So inside this, create another bracket. Put the plus in here. As you can see, this wire tracks back to B, and this wire tracks back to C. So here we have a B, and then a C. And then over here, we have another AND gate. So inside this, draw another dot here for the AND. And then as you can notice, it connects to both B and C. So once again, B and C. Now that's all that's left for us is to find it. Find whatever equation represents this. First, we can get rid of the first equation because it states that the output here is X, not Q. Then we can also get rid of this one because there's never a not in here and it flips A and it says that A equals to 0, which is simply not true. Now we have to start analyzing the thing properly. So first we should check if the centralmost gate is an OR. Here is an OR, here is an OR, and here is also an OR. So far they all seem to be correct. Now let's check for the left gate, A and B. For all of them, they all appear to have the proper thing. A equals 1 and B equals 1. Then we have the AND gate. So, as you can see, they all have the AND gates, which is true, or which is correct. Then we have the B or not, or I mean the B or C. Here we can notice that there's a C equals 0, so this means we can get rid of this option, leaving us with only these two. Then we have B and C. Here it says it's B or C, which, by the way, if you notice, that's just the same thing repeat over, so this would actually be redundant, leaving us with this option. A fire alarm system Q uses logic gates sensors A, B, and C to function. The system would be activated if sensor A or B are activated, and if sensor A is activated and sensor C isn't. So first we should write the logic expression for this. So just do that really quick. So the output must be Q, so we write a Q here. Q equals A or B, right. First we have the AND here, which is the centermost gate. So a dot here, two brackets here, and two brackets here. A or B, so we just write A plus B. And then if sensor A is activated and sensor C isn't, so A dot C with a dash on it because we want sensor C to be off. So let's draw this. First we have the AND gate in the middle, so draw the Q inputs here first, and then draw a line connecting it to a NOT. Then this connects to an OR gate over here. So let me just draw this OR gate real quick. Now we have an OR gate, which connects to an A. So let me draw this wire to A, and a B, which let me just connect this wire to a B. Next we have A and not C. So let's connect this to an AND gate. And then connect it to A first. So let's just draw a little dot here, a little hoop to show that's jumping over the wire, and we've successfully connected A to this AND gate. Now we have to connect a NOT gate for the C. So a little circle, triangle, and then C. Now we've successfully drawn the logic circuit. So now we just need to find whichever one looks like this. So we're just left with this one. Consider the following circuit. When A equals 0 and B equals 1, when A equals 0, B equals 1, and C equals 0, the output will be. Okay, so first write the input beside each one. So A is equal to 0, B is equal to 1, C is equal to 0. So first things first, 0, let's start with this, the uppermost. So 0 will go through this wire until it goes to here. So the input is 0. Since it's a NOT gate, it should be flipped to 1. Then the 1 goes through this wire until it reaches here. The input for this AND is 1. Now we have to go to the other one. Let's start with B. First, the 1 travels down this wire until it reaches the 1. Or until it reaches the OR. So let's write a 1 here. Now let's do this gate. First, it's connected to A, which we already know is 0. So let's just draw the path of the A, showing us that it's indeed is connected to A. Then we have C. We have said that C is equal to 0. And when we have two zeros, we should have when you have two zeros in AND gate, it should be 0. Now we have a NOT gate here, which flips whatever is here. So we have a 1. It then travels down this path to get 1 here. In an OR gate, either one has to be 1. So since we have both 1s, this is obviously true. Then it travels down this path until we get here. So now we have 1 and 1, leading to the output equaling 1. If one of the two sensors, the brake sensor or the engine sensor are on, then the check engine sensor Z will light on. Choose proper Boolean algebra statement. So first, it says that both sensors must be on. So get rid of anything that has a dash. Next, it says or, so either one of them have to be on. But here is an and, so you get rid of this, leaving you with this one. What is the output of this expression? X equals A and C and B and not B or C if A equals 0, B equals 1, C equals 0. So first, let's just write this down again. X equals A and C and not B or C. Now we just substitute everything. So X equals 0 and 0 and not 1 or 0. So we obviously know that 0 and 0 leads to the output of 0, and not 1 gives 0. So now we have 0 or 0, which then leads to 0 and 0, which is 0. So the output of this expression is 0. These are the following advantages of using automated systems in the transport sector. All that apply. It increases consistency in meeting delivery schedules. Yeah, because in automated systems, they're almost always consistent. There's never a change in them, unlike humans where we would cause some sort of changes. It allows more products to be shipped in a shorter time. Yeah, because usually automated systems are more efficient in their working. The cost to set up such a system is high. Although this is true, this is a disadvantage which is not being asked about. The preventative maintenance does not require manpower. This is just straight up false. Any type of maintenance always requires manpower. It can operate in nearly all weather conditions. Yeah, if it's made properly, then it can survive mostly any weather condition. Unlike serious ones like, let's say, a tsunami, tornado, all those stuff, which, to be honest, nothing is really surviving. Are small packets that are sent by the web server to the user's browser, and they're stored by the web browser on the user's computer. So let's see here. The home page is obviously not stored on the user's computer, nor is the address bar, refresh button, or reload button. So this obviously leaves cookies. Which of the following is a type of cookie? Highlight all the correct answers. So throughout this quiz, we've only encountered two real types: session cookies and persistent cookies. Something is the component that moves in response to a signal coming out of a microprocessor. Keyword here: that moves in response to a signal coming out of a microprocessor. Key phrase, which is an actuator, which is an output device. Something are stored in a file on the computer's hard disk and help the website remember valuable information, such as settings, preferences, login credentials. They are not deleted when the browser is closed, but they have an expiration date. Key phrase here: not deleted, which is a persistent cookie. Something has a specific type of database that stores data in blocks in a chronological order. Keyword here: blocks. So a blockchain.